Hi, everybody. This is Dr. John. And today I'm going to be answering a question posed by Landon H. in physics. Landon asks, a cat has a mass of 8.2 kilograms. If the acceleration due to gravity is equal to 24.8, how much would the cat weigh on Jupiter? This is a very interesting question because it highlights a key difference between mass and weight. The mass of an object remains the same in any environment, because mass is a measure of an amount of matter intrinsically related to an object. So a cat with a mass of 8.2 kilograms would have the same mass on Jupiter, Mars, Venus, anywhere in the universe, really. However, the weight of an object would change because weight depends on the environment. Essentially, weight is a measure of the force of gravity due to a very massive object. So a cat on Earth would weigh significantly less than it would on, let's say, Jupiter, because Jupiter is a huge, massive planet, much more massive than planet Earth. And because it's more massive, the force of gravity on Jupiter would be much larger. And then that force of gravity then would mean that an object would weigh more. So let's figure out exactly how much more. So let's first approach this on how would we define the weight of this object on planet Earth? And then we'd apply the same logic to determine its weight on Jupiter. So first, let's just draw a rough schematic of this is planet Earth. And in physics, we often have these free body diagrams where instead of drawing out the object, like let's say a cat, we just represent the object with a dot. And then we can determine the forces acting on that object. And if it's just at rest on the surface of the Earth, the only force would be the force of, you guessed it, gravity. So we're just going to say the force of gravity, F sub g, is equal to, now the force of gravity near the surface of the Earth is a formula which is just the mass of the object times the acceleration due to Earth. So it's oftentimes represented by just g, but because in this problem we're dealing with gravity on Earth and gravity on Jupiter, let's say g sub e. And for all objects near the surface of the Earth, this is equal to 9.8 meters per second squared. So we can substitute these quantities in. So for mass, I have 8.2 kilograms. And for acceleration due to gravity on the surface of Earth, we have, like I said, 9.8. The units are meters per second squared. And we can type that into our calculator to arrive at 80.36. The units would be kilograms, meters per second squared. These combine to give you a unit of the Newton, or just abbreviated N. Okay, so this would be your weight then on planet Earth. Okay, so I'll go ahead and box that answer. But what about on Jupiter? Well, as we kind of roughly sketched before, Jupiter is a much more massive object than that of Earth. So the same cat would have the same mass, but it would have a much greater weight. So the same cat, except this time he's made it all the way to Jupiter. But Jupiter, being a much more massive object, has a much greater force due to gravity. So we have the force of gravity on Jupiter is equal to m times g. Same formula, except instead of 9.8, we have to use the acceleration on Jupiter. So I'll just call g sub j for Jupiter. And we can plug these values in to get 8.2 kilograms times acceleration due to gravity on Jupiter, which is 24.8 meters per second squared. And this comes out to be 203.36 newtons. Okay, very good. So you can see that the quantity, as our intuition suggested, is much greater than that on Earth. But sometimes in physics, it's nice to kind of get a grasp about how much greater is the weight of Jupiter. So by that, I mean, we can take we can do a comparison of the two quantities to get a little bit more of a sense for uh, how these weights are related. So to do that, we just take a simple ratio. So let's just do a ratio of weights. And this would just be the weight on Jupiter divided by the weight on Earth. So we just take our weight on Jupiter that we calculated over here. So that would be 203.36 newtons divided by the weight on Earth, which we found to be 80.36 newtons. Newtons cancel out. It's a ratio, so we shouldn't expect any actual units. 203.36 divided by 80.36. If you plug that in your calculator, you'll get 2.53. So wow, that's quite a difference. So essentially, objects weigh 2.53 times more heavy on Jupiter than they would on Earth. So a 100-pound person on Earth would weigh over 250 pounds on Jupiter. It's quite interesting. So I hope this clears up some common misconceptions between mass and weight. And I hope I answered your question, Landon. So with that, thanks for listening. And until next time, this is Dr. John. Happy studying.